You've probably seen them 100 times. Living jewels, tiny acrobats of the air, their wings a blur of motion. We see them as fleeting flashes of iridescent color, darting between flowers with impossible speed. We know them for the hum that gives them their name, and for a metabolism so extreme it seems to defy reality. But what we see is only a fraction of their world. What if I told you that in broad daylight, they see colors that are impossible for us to even imagine, and that every single night, they must come within degrees of freezing solid just to survive until dawn? The story of the hummingbird is far stranger and more spectacular than you've ever believed. It's a story of superpower and extreme survival. The first secret isn't hidden in the dark, but in the brilliant light of day. A hummingbird's life is a frantic, non-stop search for fuel. They have the highest metabolism of any warm-blooded animal on the planet, a biological engine that burns so hot they are always just a few hours from starving. To keep that engine running, they have to consume 1.5 to 3 times their body weight in nectar every single day. For a human, that's like chugging over 1,000 cans of soda. So here's the challenge. How do you find that much food, scattered across thousands of flowers, with enough speed and efficiency to stay alive? The answer is their first superpower, their vision. See, we humans are what scientists call trichromats. Our eyes have 3 types of color-sensitive cone cells, tuned to red, green, and blue light. Everything we see is a mix of those 3 colors. But hummingbirds are tetrachromats. They have a 4th cone, one that's sensitive to ultraviolet light, a whole spectrum that's completely invisible to us. This 4th cone doesn't just add one more color, it unlocks a psychedelic world of combinations. We humans can perceive only one non-spectral color, purple, which our brain creates when our red and blue cones are stimulated at the same time, but not the green. With their 4th cone, hummingbirds can theoretically see up to 5 of these non-spectral colors, including wild combinations like ultraviolet plus red and ultraviolet plus green. These aren't just simple mixtures, they are likely entirely new colors that we have no way to imagine. For years this was just a theory, but then, groundbreaking research from Princeton University proved it. Over 3 summers at the Rocky Mountain Biological Laboratory, scientists set up special LED feeders. One had sugar water, the other plain water, with lights above them displaying different colors. Sometimes, one light was pure green, and the other was a mix of green and ultraviolet light. To our eyes, the 2 lights looked absolutely identical. But the hummingbirds were never fooled. In over 6,000 visits, they consistently and correctly chose the ultraviolet plus green light that led them to their sugary reward. As one researcher put it, the ultraviolet plus green light and green light looked identical to us, but the hummingbirds kept correctly choosing the ultraviolet plus green light associated with sugar water. Suddenly, their world makes so much more sense. Flowers that might look plain yellow to us are often covered in hidden ultraviolet patterns, bullseyes, landing strips, and neon signs, all screaming, "Nectar here." These secret messages, invisible to us, let a hummingbird scan thousands of flowers with breathtaking speed, making life or death decisions in a split second. They've cracked the code of daylight. Flowers that might look plain yellow to us are often covered in hidden ultraviolet patterns, bullseyes, landing strips, and neon signs, all screaming, "Nectar here." These secret messages, invisible to us, let a hummingbird scan thousands of flowers with breathtaking speed, making life or death decisions in a split second. They've cracked the code of daylight. But here's the catch. This incredible advantage is completely dependent on the sun. As daylight fades, the hummingbird's greatest asset becomes useless. They can't see well in the dark, so the vibrant, color-coded world that keeps them alive just vanishes. And a new, more urgent threat emerges: the cold. Their hyper-fast metabolism, their greatest strength by day, now becomes their greatest enemy. Without the constant fuel from nectar, their bodies would burn through their energy reserves in just a few hours, leading to certain starvation before morning. At the same time, their tiny bodies, which don't have the insulating downy feathers of other birds, lose heat at a terrifying rate. If they tried to maintain their normal daytime body temperature of over 104 degrees Fahrenheit, 40 Celsius, they'd burn so much energy, they'd starve even faster. This is the ultimate bind. Their superpower vision is gone. Their metabolism is a ticking clock. The cold is a relentless enemy. The question from our title, "How do they see in the dark?" is suddenly the most urgent question of their existence. And the answer is the hummingbird's second and most shocking secret. They don't. They do something far more extreme. To survive the night, the hummingbird doesn't see. It practically stops being. To conquer the darkness, it performs a death-defying feat called torpor. This isn't sleep. It's a state of suspended animation. A nightly hibernation so profound it pushes the very boundary of life itself. As the bird settles on a branch, its internal thermostat plummets. Its body temperature, normally a feverish 104 degrees, can drop by more than 50 degrees Fahrenheit, sometimes chilling to just above freezing. One species, the black metal tail of the high Andes, was recorded dropping its body temperature to a shocking 3.26 degrees Celsius, or 37.8 degrees Fahrenheit, the coldest body temperature ever recorded in any bird or non-hibernating mammal. Everything else shuts down. That raging metabolic furnace slows by as much as 95%, saving up to 50 times more energy than when it's awake. Respiration becomes shallow and may even stop completely for brief moments. And the heart, the hummingbird heart, is one of nature's most incredible engines. During the day, it can race at a phenomenal 1,260 beats per minute. But in the depths of torpor, that frantic rhythm slows to a near standstill. The blue-throated mountain gem's heart rate can drop from over 1,200 beats per minute to just 50, or even 36. Hanging there, sometimes upside down with its tiny claws locked to the perch, the bird is clinically dead to the outside world, cold, still, and unresponsive. It's a nightly gamble, a controlled descent into a state just barely clinging to life. Torpor solves the problem of the night, but it creates a new, equally dangerous one in the morning. How do you come back from the brink of freezing solid? The process of waking up isn't gentle. It's a violent, explosive revival. About an hour before sunrise, with no cue from the light, an internal clock triggers the awakening. The first step is to shiver. But this is no ordinary shiver. The hummingbird begins to vibrate its powerful wing muscles, the same ones it uses for flight, contracting them with incredible speed. This internal friction generates a massive amount of heat, warming the bird's blood. As the warm blood circulates, its heart rate and breathing begin to climb, and its body temperature rises by several degrees every minute. For up to an hour, the bird is trapped in this vulnerable, groggy state, shivering violently just to drag itself back to the world of the living. It's a process that consumes a huge amount of the precious energy it saved overnight. Then, almost as if someone flipped a switch, its eyes open, the shivering stops, and with its body temperature restored, it explodes from its perch, reborn into the dawn, desperately hungry and ready to begin the frantic search for nectar all over again. The hummingbird lives a life of breathtaking extremes, a creature of two completely different worlds. By day, it's a master of light, navigating a hidden reality of ultraviolet signals that we can't even comprehend. It's a superpower that lets it solve the relentless puzzle of its own blazing metabolism, and by night, it conquers the darkness not by seeing, but by surrendering to it. It enters a state of near death, shutting down its body to survive the cold and the dark. Each sunset is a step into oblivion, and each sunrise is a violent, hard-won resurrection. So the next time you see one of these tiny jewels hovering in the air, a blur of motion in the summer sun, remember its secrets. Remember the world of impossible colors it sees in the light, and the extraordinary journey it takes every single night, a journey to the very edge of existence and back, just to survive until dawn. If you were amazed by the hidden world of the hummingbird, be sure to subscribe and hit that notification bell. There are countless other secrets in the natural world just waiting to be explored, and we'll be here to discover them together.